You know the story. A princess pricks her finger on a spinning wheel, falls into a deep sleep, and doesn't wake up for 100 years. A whole castle falls asleep with her. Vines grow over the walls. Dust piles up. And then one kiss, and she opens her eyes like no time passed at all. It's a beautiful story. It is also scientifically completely impossible. And today we're going to find out why, by taking apart what sleep actually is, what your brain is doing right now every single night, and whether humans could ever really pull off something like Sleeping Beauty's 100-year nap. Spoiler, astronauts are actually trying to figure this out for real space travel. Let's get into it. Quick recap so we're all on the same page. A king and queen finally have a daughter. They throw a huge party and invite fairies to bless her. One fairy wasn't invited, gets furious, and curses the baby. On her 16th birthday, she'll prick her finger on a spinning wheel and die. Another fairy softens the curse. Instead of dying, she'll just fall asleep for 100 years, until a prince wakes her. 16 years later, it happens exactly like that. The whole kingdom falls asleep along with her. A forest of thorns grows around the castle. 100 years pass. A prince cuts through, finds her, and she wakes up. Great story. Now let's talk about what your brain actually does when you sleep, because it is way weirder and way more interesting than a magic curse. So, what's actually happening in your brain when you sleep? Here's the biggest myth to bust right away. Your brain does not turn off when you sleep. It's not like flipping a light switch. It's more like your brain switches into a completely different mode of working, and it's incredibly busy. Every night, your brain cycles through different stages, about every 90 minutes, over and over. Sometimes light sleep. Your body temperature drops, your heart rate slows, and you're easing out of being awake. Sometimes deep sleep. This is the stage where your body does its heaviest repair work. Growth hormone gets released. Your muscles rebuild. Your immune system does maintenance. This is a huge part of why kids and teenagers need more sleep than adults. You're literally still under construction. Sometimes REM sleep. REM stands for rapid eye movement because your eyes actually dart back and forth under your closed eyelids. This is when most dreaming happens. Your brain is very active here, almost as active as when you're awake. But your body is temporarily paralyzed, so you don't act out your dreams. Scientists think REM sleep is when your brain sorts through everything that happened during the day, deciding what to file into long-term memory and what to toss out. Here's the part that would blow Sleeping Beauty's mind. While you sleep, your brain also runs something like a cleaning crew. There's a system in your brain called the glymphatic system that flushes out waste products that build up while you're awake, including a protein linked to brain diseases later in life. Your brain quite literally washes itself while you sleep. You can't do that awake. It only works properly during sleep. So the honest answer to what's happening in your brain while you sleep is repair, memory filing, and cleaning, all at once, every single night. Could your brain survive 100 years of sleep? Now here's where the fairy tale falls apart. Sleep is not a pause button. Your brain needs a constant supply of oxygen and glucose. That's sugar, basically, to survive. Even in deep sleep, your brain is still burning through energy non-stop. If it didn't get that fuel, brain cells would start dying within minutes, not decades. So 100 years of ordinary sleep isn't a longer nap. It's not biologically survivable at all. Sleeping Beauty's castle would need actual magic to keep everyone's brains fed with oxygen and sugar for a century, because normal sleep physiology simply isn't built for it. Your longest possible unbroken sleep record, for comparison, is measured in days, not years. And honestly, going that long without sleep at all would be more dangerous than not sleeping enough. Does your body burn energy while you sleep? Yes, a lot more than people expect. Sleep is not resting in the sense of using zero energy. Your heart is still beating, your lungs are still breathing, your brain is still running that whole repair and cleaning operation we just talked about, and your body is still keeping your temperature regulated. In fact, some of that deep sleep repair work, building muscle, releasing hormones, actually costs more energy per minute than a quiet moment of just sitting still awake. Your metabolism does slow down overall during sleep, typically somewhere around 10 to 15% lower than your resting metabolic rate while awake, but it never gets close to zero. This is exactly why you wake up hungry. Your body has been running its systems and repair crews all night on the fuel you gave it the day before. Can science actually make someone sleep longer? Real scientists actually do care about extending or protecting sleep, just not for 100-year naps. Here's what real sleep science focuses on. Number 1, circadian rhythm. Your body has an internal clock, roughly 24 hours long, controlled by a tiny brain region that responds to light and darkness. Keeping a consistent light and dark schedule is the single most powerful tool for getting good, long, quality sleep. Number 2, melatonin. A hormone your brain releases when it gets dark, signaling that it's time to wind down. It doesn't knock you out like a spinning wheel curse. It just nudges your body towards sleep. Number 3, sleep pressure. The longer you're awake, the more a chemical called adenosine builds up in your brain, making you feel sleepier and sleepier until you finally crash. Caffeine, by the way, works by blocking your brain from sensing that chemical, which is part of why it's not a great idea for growing kids. So real sleep science isn't about making sleep last 100 years. It's about making the sleep you already get more consistent, deeper, and better timed with your body's natural rhythm. What about space travel? Could we freeze ourselves like in the movies? This is where things get genuinely futuristic, and this is real research, not just science fiction. If humans ever travel to somewhere like Mars, or further, the trip could take many months or even years. Carrying enough food, water, and air for a long, fully awake crew is a massive engineering problem. So scientists have seriously studied an idea inspired by animals, torpor. Torpor is a real biological state. It's what animals like ground squirrels and some bears use to survive winter. Their body temperature drops, their heart rate slows dramatically, and their metabolism slows way down, so they burn far less energy over a long stretch of time. Space agencies and researchers have looked into whether humans could be put into a similar state, sometimes called torpor-induced hibernation for long space missions, by carefully cooling the body a few degrees and slowing metabolic processes. But, and this is important, humans cannot currently survive real hibernation like a movie's frozen cryopod. We don't have the biology bears and squirrels have for it, and safely slowing a human body's core processes without causing organ damage is still an unsolved problem. So here's where the fairy tale and the science finally meet. Sleeping Beauty's 100-year sleep couldn't happen in real biology. Brains need constant fuel, bodies keep burning energy, and nothing we know of can pause a human for a century and bring them back unchanged. But real sleep is still astonishing on its own. Every single night, without any magic at all, your brain repairs your body, sorts your memories, and literally washes itself clean, all while you're completely unaware it's happening. That's not a fairy tale. That's just what your brain does for you, every night, for free.